Hey, welcome to the Explainer. Today, we're going to try and demystify the world of big data by diving into the incredibly powerful and foundational Hadoop ecosystem.
So to really get our heads around this, let's start with the big question you see here. And look, we're not talking about gigabytes or even the terabytes you might have on your home computer. No, we're talking about petabytes. I mean, a scale of data so mind-bogglingly massive that the tools we'd been relying on for decades just, well, they completely broke.
And that's really the crux of it, isn't it? It's one thing to just buy a mountain of hard drives to store all this information, but it's a completely different challenge to actually do anything useful with it. This dual problem, storage and processing, is what forced a totally revolutionary new approach.
So, how did the tech world respond to this huge challenge? Well, the answer was a foundational, open-source project that would pretty much change everything: Apache Hadoop.
Okay, so the first thing you've got to know is that Hadoop isn't just one single program. It's a whole ecosystem of different tools that are all built to work together, and it was designed from the ground up with three key things in mind. One, it had to be scalable, so you could just keep adding more cheap computers as your data grew. Two, it had to be fault-tolerant, meaning if one machine in your cluster dies, the whole system just keeps on chugging along. And three, because it uses that standard commodity hardware, it's way more cost-effective.
All right, so the genius of Hadoop really comes down to these three core pillars. First up is HDFS, which is the storage layer. Think of it like this. It takes your massive files, chops them up into pieces, and scatters them across a whole bunch of machines for safety. Next, you've got MapReduce. That's the processing engine. It's like having a huge complex job and dividing it up among thousands of workers who all do their little part at the same time. Then you just collect and combine their answers. And finally, you have Yarn. Yarn is the manager, kind of like the brain of the whole operation, making sure all the different jobs have the computer resources they need to run efficiently. So you've got this unbelievably powerful system, but there was a catch, a big one. It turns out that writing the code for MapReduce directly is notoriously difficult and complex. So that created a brand new problem. How do you make all this power accessible to, normal developers and analysts?
One of the first big solutions came from Yahoo with a tool called Apache Pig. And the idea behind it was honestly brilliant. They created a much simpler scripting language called Pig Latin, which is a great name, that lets developers just describe the flow of the data they want. Pig then takes that simple script and, behind the scenes, automatically translates it into the complicated MapReduce job for you.
And you can see immediately how much cleaner this is, right? I mean, even if you're not a coder, you can pretty much read this like plain English. It's loading data, filtering it, and then grouping it. This is worlds away from writing hundreds of lines of really complex Java code to do the exact same thing.
Okay, so that's great for developers who like scripting. But what about the millions of data analysts out there who live and breathe SQL? They definitely don't want to learn a whole new language. For them, the community developed Apache Hive. Its entire mission was to provide a familiar, SQL-like interface on top of the massive datasets stored in Hadoop.
And yeah, this should look super familiar to anyone who's ever touched a traditional database. It's SQL. It's just SQL. By offering this interface, Hive basically opened the floodgates to big data for all these analysts and business intelligence professionals who could now use the skills they already had on a completely new, massive scale.
And this distinction is absolutely crucial. A traditional database, an RDBMS, is like a bank teller. It's built for fast, individual transactions. That's called OLTP. And it needs a very strict structure up front, or a schema on write. Hive, on the other hand, is like a historian. It's designed to analyze huge archives of past data. That's OLAP. It actually figures out the structure as it reads the data, a super flexible approach called schema on read. They're totally different tools for very, very different jobs.
All right, so we've made things easier for developers and analysts. But what about other big challenges? Like what if you need to grab one specific piece of data right now? Or what if you need to connect this shiny new world of Hadoop to your older, existing database systems?
Well, for that need for speed and real-time access, we've got Apache HBase. It's what's called a NoSQL database, and it was modeled after a groundbreaking paper from Google about their system, Bigtable. It actually runs right on top of HDFS, and you can think of it as a massive, super-fast, distributed index for all of your big data. And it's these features that really give HBase its superpowers. For example, being column-oriented means if you have a massive record with 1,000 columns, but you only need one piece of information, HBase only reads that one piece, making it incredibly fast.
It is built for these kinds of quick, random lookups, which is exactly what you need for things like real-time fraud detection or personalized recommendations, where every single millisecond counts.
Okay, last piece of the puzzle for now. How do we solve that integration problem? What if you need to combine insights from your brand new data lake in Hadoop with data that's sitting in a decades-old enterprise data warehouse? Well, that is precisely the problem that Big SQL, an engine from IBM, was built to solve.
And its killer feature is something called federated querying. This means you can write a single SQL query that pulls and joins data from completely different systems all at the same time. You can grab data from your Hadoop cluster, an old Oracle database, and a NoSQL store, all in one shot. You can imagine that for large companies, this ability to bridge the old world and the new is just incredibly powerful.
Okay, we've looked at a bunch of individual pieces, so let's take a step back, zoom out, and really see how this whole thing fits together as one cohesive ecosystem. You know, probably the best way to wrap your head around this whole ecosystem is to think of it like the infrastructure of a big, modern city. HDFS is the city's massive, resilient warehouse where everything is stored. MapReduce and Yarn are the power grid and the city planner, managing all the resources and energy. Pig and Hive are like prefab construction kits and a universal query desk, making it way easier to build things. HBase is the high-speed subway system, giving you instant access across town. And Big SQL, that builds the bridges connecting your city to all the other cities around it. So look, if there's one big takeaway here, it's this. The Hadoop ecosystem isn't just a single product. It's a powerful and incredibly flexible framework. It gives you a layered set of tools to solve an entire spectrum of big data challenges, from these huge, long-running analytical jobs all the way down to instant, real-time access.
And that leaves us with a really interesting question to think about. The problems these tools were built to solve, they're only getting bigger. With the amount of data in the world growing exponentially, and with AI demanding more and more complex processing, it really makes you wonder, what innovations and what new tools will make up the next generation of this ever-evolving ecosystem?